Welcome to qnawire.
This is the figure given in the question. So here the P is given as 0 in question, and the Q that is given as minus 900, negative 900 Newton, and this one is actually along K. Okay, yeah. Now here there is two support at point D, so that creates two reactions. That's right. Yeah, that creates two reactions. One along X, this will be dz, and this will be dy. Yeah, and here there is only one reaction that creates cy, and here this is a principal, so there will be reaction along all the direction. So that means there will be bz and by and also bx. Okay, yeah, and the distance, everything is given in meter. Now apply equilibrium equation in 3D. So summation along h equal to 0 gives you bh equal to 0, and summation along z equal to 0 gives you dz dz minus the, so dz minus 900 equal to 0. So, and the summation of momentum at b equal to 0 gives you 3 meter into dy minus 3 meter into q equal to 0. We know the value of q, substitute the value of q here. That gives us the value for dy. Therefore, dy will be 900 Newton. Okay. Now summation at momentum E. Yeah. Momentum E equal to 0 gives you 3 meter into d z and actually, yeah, this is from the point B, so, and this is the momentum at point C, so that's why the dy is 3 meter away. Yeah, so here dz minus to avoid confusion, this is along K. Okay, yeah, 3 dz minus of 0.6 meter times q equal to 0. So this gives us the value for dz, that will be 300 Newton. So Here, substitute the value of dz in this equation. That gives us the value for bz. That will be minus of 600 Newton. Okay, and summation of momentum B along J equal to 0 gives you, so that means 1.8 meter into dy plus 1.8 meter into cy equal to 0. So from here you will get cy will be equal to minus of dy, that will be equal to minus of 900 Newton. We got the value of dy here, so cy will be minus 900 Newton. Now summation along y equal to 0 gives you by plus cy plus dy equal to 0. Okay, yeah, and from here substitute the value of cy and dy. Actually those are negatives. Cy is minus dy, so that means by is 0. Okay, yeah. Now let's move to joints and solve for each joints. So first let's take joint C. So for joint C, the joint C connects members AC, BC, CE and CD. Let's first find the distance AC. That will be root of 1.2 meter square plus 3 meter square plus 0.75 meter square. So root of this value gives you 3.317 meter. And now distance CE equal to root of 1.8 meter square plus 3 meter square. Okay, so this gives you 3.5 meter. Now let's find the vector FAC. Vector FAC will be equal to the magnitude of FAC divided by the magnitude of AC, that is 3.317 into vector AC. Vector AC is actually 1.2 I plus 3J plus 0.75 K. Okay, so dividing this by this gives you 0.362 I plus 0.9 J plus 0.226 K times FAC. Okay, now let's find the vector FCE. Vector FCE will be magnitude of FCE divided by magnitude of CE, that is 3.5 into vector of CE. Vector of CE will be minus 1.8 I plus this is I 3K. So dividing this one gives you minus of 0.514 I plus 0.857 K times FCE. Okay, and the vector FCD. is actually the LCD, and this is only around K. Yeah. Now let's draw the diagram for joint Z, so that gives you a better understanding for further solving. So for joint C, if this is joint C, then FCD and there will be FBC. Sorry, it's FBC, and the CY and the FCE and FAC. Let's draw the directions also. So this will be y-axis, this will be x-axis, and this will be z-axis. Now component at j direction. Component at j direction. To get the component at j direction, we need to find summation along y equal to 0. So that gives you 0.9 FAC minus 900 equal to 0. So from here, therefore, FAC will be equal to 995.1 Newton. So here FAC is actually going outward, that creates tension. Let's denote it by the letter T. Now component at I direction. Component at I direction. To find the component at I direction, we need to find summation along h equal to 0. So that gives you 0.362 FAC plus 0.514 FCE, equal to 0. So from here we know the value of FAC. Substituting value of FAC in this equation gives you the value for FCE, that will be minus of 699.8 Newton, and the FCE is actually going outward, from the point C, but because of the negative sign in the solution, the actual direction is going inward to the point C, so that creates compression. Let's denote it by the letter C. Yeah. Now component at K. At K direction, to find the component at K direction, we need to find summation along Z equal to 0. So that will be 0.226 FAC plus 0.857 FCE plus FCD equal to 0. So here substitute the value of FCE and FAC in this equation. That gives you the value for FCD, which will be 375 Newton, and You can see FCD is 375 Newton. Actually, the FCD is going inward to the point C. So that creates compression. Let's denote by the letter C. Now let's move to the next joint, that is joint D. So joint D connects members DA, DC and DE. So let's find the distance of AD, that is DA. So AD or DA will be 1.2 meter square plus 3 meter square plus 2.25 meter square. Root of this value gives you 3.937 meter. Now let's find the vector. Vector FAD will be magnitude of FAD divided by the magnitude of AD, that is 3.937, into vector AD, that will be 1.2i plus 3j plus 2.25k. Yeah. So next is vector FCD. We got the value of FCD, that is 375 Newton, and that will be around k. Okay, and vector FDE, that will be minus of FDE in the direction I component. Okay, now let's draw the diagram for joint D. Let's use that. If this is joint D, there will be dy dz FCD FDE and FAD. Let's draw the axis. Yeah, this is x-axis, so perpendicular to this. Here this will be y, and perpendicular to both this will be z, c-axis. Okay, now for the joint D, component at j direction, component at j direction. So to find the component at j direction, we have to find summation along y equal to 0. So that gives you 3 by 3.937 times FAD plus 900 Newton equal to 0. So therefore FAD will be equal to minus of 1181.1 Newton, and the FAD, there is a negative sign here, so the actual direction of FAD will be opposite to this direction. That creates compression. Let's denote it by the letter C. Now component at I direction, component at I direction. So to find the component at I direction, we have to find summation along h equal to 0. That gives you minus of 1.2 divided by 3.937 times FAD minus FDE equal to 0. So substitute the value of FAD from here in this equation. That gives you the value for FDE. So FDE will be equal to 360 Newton. And you can see from the figure that is FD is going inward. So the here actually there is a negative sign here. So if this goes to the right hand side, FDE will be minus of FAD. So this minus and this minus will cut off and that become positive. So here the direction of FD is going inward. That creates compression. So let's denote it by the letter C. Now let's move to the next joint, that is joint B. Let's first draw the diagram for joint B. So if this is B, there will be FBC and BH, not BH, BZ, that is BZ and BY, and here along this direction this will be BH, okay, and FAB, so it will be like this, yeah, and the FBE. Now let's draw the axis. This will be x-axis, okay, and this will be ZC axis. This will be Y axis. Now actually here the node B is aligned with member BE. It is as the node B is aligned with the member BE, the force FAB and FBC will be 0. Now let's move to the next joint, that is joint E. So joint E. So for joint E, if consider this is joint E, there will be FDE and FCE and FBC and FAE. Okay, let's denote the axis. This will be x-axis, perpendicular to that. This will be Y, and this will be ZC axis. So actually here the thing is AE is actually a zero force member. Okay, is a zero force member. So here we got the result as FCE, the value of FCE. After substituting, you will get 3959.7 Newton along I plus 599.73 Newton along K. Then we will get FCD 375 Newton, that will be along K, and the FAD will be minus of 360 Newton along I plus 900 Newton along J plus 675 Newton along K. And next we got FDE, that is actually minus of 360 Newton, and that is along I. And one more, we got FBE also. So we got the value of FBE, substitute the value, so that gives us 600 Newton, and this is actually along K. Okay, so this is the result. I hope you understood the problem. Thank you.